is covering correctly, no? Slide is covering correctly, right?
Many of them you are already working on it for quite some time, and it's a great opportunity for you. And all the experts are here. Please, on this end, and try to ask questions to get in depth more understanding of that. And so we have divided into 3 tracks. I hope everybody is aware of that. That front-end track, data track, and
Backend.
Yeah, the backend application, services part. So once we have finished this session, then again we will go to the respective rooms where each individual sessions will be conducted. Okay. So.
Sure. We good to start? Okay. Thanks.
Yes.
Okay. Good morning, everybody. Good morning. My name is Mathew, and I'm from this organization called Xstep Foundation. Okay. At Xstep, I had engineering and implementation. So, before we get started, with the actual session, Mathew, I'm going to take 5 or 10 minutes of your time.
Sure.
I hope that's okay. I wanted to set a context for all of you. And I just want to give you a quick background on what exactly has happened in the last 6 years. Okay. We are here because we are actually helping build on Diksha. Okay. Diksha is the country's largest education platform. And for me, I was super proud when we were actually running with Diksha over the last 5 years. Okay, the kind of scale that we have seen in Diksha, I definitely want to stand up and say that I don't think there's any other organization has seen the kind of scale that we have seen for Diksha in October 2020 or during the pandemic. The kind of numbers that we saw were really, really, really huge. Okay, so just to give you a sense, and this is a number I will never tire of telling anybody over here, and this makes it all the more relevant for all of you out here because you're a pure tech audience. If you have probably been following Diksha's telemetry and things like that, in the first 3 years, we actually clocked 62 billion minutes of content play. That's the kind of numbers that we hit. Okay. And I would really like to say that each one of you who are actually going to be working on Diksha should be proud of this. And something that completely energizes the old, the Sunbird team is, we consistently keep telling them every single line of code that you write impacts at least 200 million children in India. Wow. Okay, and look at it from that perspective. I mean, don't look at it just as a project, just as a solution. Every single line of code that you write is making a difference to every single child in the country. Okay, and if you look at it from that perspective, we're really talking about passion coming in on play, and we're talking about we making a difference to the country in one of the largest education platforms over here. So just to give you a history again, Diksha, even during the peak pandemic, it was not just used for education alone. The country at that point of time, when they were really looking at how to train the frontline workers, the only solution that they could find at that point of time was Diksha. So we had explicit requests coming from multiple ministries saying that, hey, listen, the pandemic is hitting, we don't know how to reach the frontline workers, we don't know how to reach Asha workers, Anganwadi workers, the scouts, guides, NCC cadets, what do we do? The Ministry of Education actually offered a tenancy on Diksha to take this platform for multiple people to get trained. So, and I want you to wear this lens, so we are consistently, please wear this lens, What you're actually building for is one of the, probably the largest platforms for the country. It's actually making a difference to people and at multiple levels. That was about, and this frontline workers training was called IGOT. Okay, probably since all of you work on Diksha very closely, but I've actually noticed there's still a tenant on Diksha which is called IGOT. That tenant was a short-lived tenant which was actually to do frontline workers training at that point of time. So that was about IGOT. But this also has seen one of the biggest, actually I think there are about 4 or 5 instances training for the teachers. There was this large program that was called NISTA, which was launched in, I think, 2019 and 2020. NISTA 1.0, 1.2 thing. And Diksha was able to show to the country a saving of over 95% on cost, which traditionally trainers would have to come to a location, they would have to pay TADA, they'll have to do a lot of things. Diksha was actually used even for trainers. And that was again one of the largest trainings that have happened. I think NCRT used to proudly say that this was probably the largest teacher training ever done in the world on a digital platform. NCRT used to actually talk about it. I don't know whether you know, Diksha has actually got multiple awards. There was a UN award that was, which Professor Behera proudly shows in his room. Okay, primarily because how Diksha was leveraged during the pandemic, and this was against the census that was taken across all the countries. Diksha, India won this award, and Professor Behera actually went to receive this award, if I'm right, in Paris. He actually went to do that. So please look at this as a system, as a solution, as the country's largest infrastructure that is actually being used for learning. Okay, and then your approach, the way you look at it, will completely change. And Diksha doesn't stop here. Each one of you have the capability to go and build on top of this. Yeah. Okay, and the very idea of we talking about Sunbird is an open source. The idea is understand what is there, understand every single line of code over here, and you can take Diksha 2.0 to greater heights. Okay, and again, the biggest advantage of doing an open source is otherwise we are constrained with our imagination. When you're doing it something like an open source, you're opening this up to everybody else. People can imagine new solutions. And that's one thing that we have truly believed in when we started building Xstep. It's not just about building what we know, it's about building beyond that, letting the ecosystem come and play over here. Okay, so if most of you would have heard, there was also a big program that was launched by MOE called NDIR. Have you heard of NDIR? Yeah. It stands for National Digital Education Architecture. Okay, that was an architecture which opened up Diksha for the ecosystem to let them come and play and build solutions on top of that. While the code Diksha is maintained, you can actually go back and the APIs are opened up so that anybody can come and build solutions on top of that. And in the early days, there were some very interesting use cases that were actually spoken about. We had somebody like a Doubtnet who came and said, we are willing to offer a solution free of cost. They were, do you remember, Krishna, do you remember any of the names that had come on? We had about 70 odd companies that came and showed interest in giving the solutions to Diksha. We had at least about 6 or 8 states, Maharashtra, Assam, I think one state in South India came and said, please take our front-end solution. So you should reimagine Diksha. Don't look at this as one monolithic solution. When you're talking about, when we are learning about the APIs, just imagine how you can actually power the entire nation. So what you're actually saying over here is, there is no stopping Karnataka from having its own app, or Manipur, or Rajasthan from having their own app, but powering with the same backend. Yes. Anybody can, you can do any kind of thing in this entire game over here. So look at it from that perspective. My humble submission is come in with an open mind, see how we can really play the game, how we can actually leverage it and build on and make a much bigger impact than Diksha 2.0. So specifically about the training, I think Rajesh has explained that we'll be having 3 tracks. We'll have a front-end, back-end, and a data track. We'll have the front-end track in this specific room. So after we finish the general session, other people move on to the other rooms. Room 3, which is on your right side, when you walk out on the right side, that will host the back-end track, and the room 2 will actually host the
data track.
Yeah, the data track over here. So that's the way we'll actually be dividing ourselves. The focus of the training would be on 5.1, the version that is actually used for Diksha. While Sunbird has moved on, we'll be working on the 5.1. The another key thing that I definitely wanted you to know is, I'm not sure whether a lot of you know, even though I'm introducing myself as Xstep Foundation, Xstep does not have an engineering team. Okay, I have 0 engineers. And this was a construct from day one, from 2015 when we started, we still have 0 engineers. Our entire solution has been built with our ecosystem partners. So Mathew represents Tarento, and he actually heads the Center of Excellence for Tarento. They're actually working on IGOT, UPSMF, Astrika, NULP also from right?
Yeah.
NULP, yeah. So these are the 4 projects that they are leveraging Sunbird on outside. Okay, and I'm really happy to have Mathew here because he has been an early architect for Sunbird. So fundamentals, the tech stack, a lot of those things actually have come out of Mathew's thought process. So happy to have Mathew here. We have representation of this training actually from organizations like Good Work Labs who will actually be helping us with the front-end training. I think Swanjit is traveling from Bhubaneswar. Swanjit is traveling from Bhubaneswar. He's coming in from Bhubaneswar. We'll have folks coming in from Pune. That will be from Tekti, and they will be handling the entire co-create part of it. Yeah. We'll have Samagra, who's actually coming in from Delhi, who will be handling The UCI component of it, yeah. We'll have Shiksha Lokam. Shiksha Lokam is another foundation that they have their own tech vendors. They have Tuner Labs and Pace Wisdom, who actually develop the managed learn components for Diksha. So even when we built out Sunbird, it has been a community effort. So a lot of organizations came together to actually build it out. And of course, we have Mahesh over here, who represents Sanketika. Sanketika also has been a very early partner for actually building the entire architecture grounds up for Sunbird. So did I miss out any organizations, Krishna?
So many.
The NIIT is there. We have NIIT. We have Kumar Gaurav coming in from NIIT.
Samagra.
No?
Samagra.
Samagra I spoke about, yeah. So we'll have quite a few organizations, about 8 or 10 different organizations, people coming in from across the country to actually help leverage on this training, help you actually on this training. So let's make the best use of it. And like we said, the intent is to go bottoms up, code level. We are going to be talking about a code walkthrough over here. So please feel free to ask your questions. All the APIs, we'll be covering all the APIs. That has been a repeated request. We'll be talking about the dependencies. We'll be talking about the databases that are leveraged over here. So all of this is going to be a part of these 5-day training that we are talking about. So I think Oracle will also be having some sessions on the last day where they will actually be doing some Oracle-centric trainings over here. So let's make the best of the next 5 days. Any questions, starting questions that you would have? Anybody? Okay, great. Over to you, Mathew.
Thank you, Madhu. So good to be here, talking to all of you about some of our thinking from 6 years ago and then how the journey has been. I want this session to be as interactive as possible because if you hear some keyword that is not familiar, stop me, ask me questions. Okay. So we started the journey of building Sunbird 6 years ago, and at that point it was very clear that we had to build a platform that can scale for India. And India, being a very diverse country, we have so many state education boards, we have so many different stakeholders, different kinds of end users. So it is very clear that we have to build something which is very generic, something which can be molded as the journey progresses, right? And that is why we thought that it is important to, follow a building blocks approach. What is a building blocks approach, right? I mean, if you look at those keywords on the right, a Lego architecture, being data-driven and being API-driven. So, when you say Lego architecture, it means that you have smaller components which are composable, and it is not just enough that you can compose them, you should be able to kind of configure them to your use cases as well, right? So, the configurability, the composability, all that is very important when it comes to a building block, right? And when you're building a system for scale, it is very key that you want it to be data driven. You want to know how are users interacting with your system, how is your code interacting with the infrastructure. You want to kind of have that visibility. Because Madhu spoke about some metrics. Hi, Sonji. Yeah, so Madhu spoke about some metrics, right? I mean, in 2020, when we hit, when Nishta was on the platform, there were days when we used to have 40 to 50 million content plays, right? And these are course plays, so the team will know, right? I mean, 50 million content plays would imply so many progress updates. So the transactions per second, the API calls per second was reaching almost like 25,000, right? So some of these things, the data-driven aspects of it really helped us understand how the system was being used by the end users, and also, how was the infra utilization. And I mean, both of these elements are key, right? And API driven. Now, it is not just one team which has to, it's not just about like building a system which has a front end, which has APIs, and then you're it. You actually want others to innovate. When you have APIs, you're letting others think how can those APIs be leveraged in contexts, in different contexts than what the creators of the APIs have imagined, right? And the world is increasingly moving towards APIs, right?
Mathew,
Yep.
can I interrupt you once in a while?
Yes.
I wanted to really talk about the number of telemetry events that you got at the peak when you spoke
Yeah,
about 50 million.
yeah. So yeah, I think the metrics is something very dear to all of us because it was a proud moment for any engineering team, right? I mean, so we hit 25,000 plus transactions per second, and it's not like just a single peak or something. We had like consistent usage over a few months at that. When we were getting these 40 to 50 million content plays, we were getting 1.5 billion telemetry events.
Every day.
Every day, every single day. So the data pipelines that you're going to focus on in the data track, they are capable of crunching billions of events in a day, right? And just on a side note, in recent times I was the telematics architect at Ola for their EV stack, and there I've implemented the same Sunbird Obsrv solution, and it's getting to 4 or 5 billion events, without a sweat. So that's the kind of scalability of the data stack. And I have a slide talking about the data architecture as well. Right. So I think these are some of the key aspects of our thinking. Like when you want to use a building blocks approach, you want things to be. You have to assume that sometimes you will have to throw away what you've already built and probably rebuild, because it's your end users and who will decide like what they need of the platform, right? So that's on the Lego thinking. Any queries on this slide? Okay. So I'll move on. So like I said, when you build anything that is for a very diverse audience, anything where it's going to be a journey of a few years and you don't know what the end shape would be, building blocks are essential. That's what we covered. And these are some of the building blocks in Sunbird. Now, I've put DevOps and infra as the bottom layer. Without automation, without monitoring, log aggregation, and some of those capabilities, anything that you build is not maintainable, is not manageable, right? Especially at scale. You can have small systems without these aspects, but anything that you build for scale should have a solid foundation of automation. Like the ability to say that none of my production deployments are going to be, maybe the trigger would be manual, but you don't need a human being to remember like what exactly has to be done for this to be replicated in another environment. That is a very key ability. So DevOps and infra is a very key focus area. If you look at the Sunbird platform, you would see that any deployment, anything that you touch has these elements in there, right? And then some of these building blocks, I'm sure most of them are used in Diksha. I would talk about Sunbird Telemetry. So because data is important, we first started off by creating a specification saying what do we capture? What data do we capture in an event? So we tried to say who did what in what context. Those are the kind of things that we want to capture. And if you look at the telemetry specification, that's exactly what it contains. Okay, you then have knowledge, which is kind of the heart of the system. So I will be deep diving into knowledge in the next slide. So I'm not going very detailed there. So you have QML, which is how do you represent questions on the platform. So you have knowledge, which is representing content. How do you represent questions? Because questions are a very valuable asset, if you ask. The amount of effort required to create good question banks is humongous. So interoperability becomes important. Like if Diksha has a nice question bank, then any state board should be able to leverage it even on systems other than Diksha. So how do you plan for interoperability? That is when you create specifications and you build to a specification, because then somebody can build to that specification and reuse the question banks as well. So QML is the question specification. And then knowledge represents content, right? And the associations, content as a graph. So we'll go into that detail. But it's also important to have the overlay of users and the users being able to track their progress and get credentials and things like that, right? So that's where the layers like Lern and there are a bunch of things. So you can spend probably hours on this slide, but we'll probably in the next set of slides we will look at what are some of the important building blocks that we want to touch upon from an architecture standpoint. And before I deep dive into the components, what are some of those design principles that we wanted to use, right? So we wanted the systems to be non-blocking and resilient, right? Everybody wants systems to be resilient. You don't like failing systems, right? We as consumers, we as engineers, we don't want to build systems that we hear are failing all the time. And we as users are, like a 3-second latency is like too high these days, right? So being non-blocking and resilient was one of our core principles. And some of our tech choices that you will see are based on these principles, right? We wanted the entire stack to be horizontally scalable without a single point of failure. What does that mean? Now imagine a system which is a small system that is built. Let's say it has a front end, it has some services, and it has a relational data store. Now, with a relational data store, you are locking yourself into a single master data source. You can have multiple read replicas for reading, for scaling out your reads, but essentially the number of writes you can do is limited to what that single master machine, and you can have only one master at any point of time because they need to support ACID properties and things like that. You cannot have it with multiple masters.
We are also binding the schema visualization.
Yes.
That cannot expand.
Exactly. Expanding a schema in a relational DB. Most of the people think that, we have alter table, you can always add a new column. But believe me, when you have a billion entries in a database table, an alter table is going to take half a day to run, right? So it doesn't work at that scale. So we were very clear that the database choices that we make, of course, the APIs are relatively, for the last decade, the industry thinks that APIs have to be horizontally scalable. You don't store state, you should be able to add more replicas and it should just be able to accommodate more traffic. But databases being horizontally scalable are relatively just catching up. Of course, the Twitters of the world, the Amazons of the world, the biggies of the world have cracked it a decade ago, but for products being built, yeah. So we chose databases which we are sure can scale, right? You can add more nodes and it should just accommodate more traffic, right? Event-driven design. So I spoke about how important observability is. Async behavior and observability are important. So non-blocking does not essentially mean async, right? They have some linkages, but there are some subtle differences. Async means the ability to say that I would publish that some event has happened, and then there is somebody else who is probably interested in that event and acting on it that I am not aware of. That is also async, right? So event-driven design is about how can you have events being generated by the various components on the platform, and how can other participants on the platform react to those events, right? That's one. Secondly, the telemetry part of it. How can the platform generate events to just make it observable, right? So those are the aspects of event-driven design. Cloud native. So all of us, while building systems, we want to leverage the elasticity of the cloud. But what comes with that is sometimes a vendor lock-in. And that's definitely not good, right? Because you will be able to negotiate better prices, you'll be able to do, use better technologies if you're cloud agnostic. So it is important that you be cloud native, leverage the power of the cloud, but know what it takes to move to another cloud, right? And I can talk from the projects that I work on. Sunbird, so Madhu spoke about a couple of projects. I got Karmyogi. That is running in NIC's cloud, okay? And Sunbird works on NIC cloud. UPSMF runs on GCP. So Sunbird runs on GCP, right? Astrika runs on AWS. So Sunbird is on AWS as well. And most of this team would know that, Diksha was earlier on Azure and now on OCI. So we've tried to see ensure that the platform that we've built can be runnable on multiple clouds. Of course, there will be some new cloud provider that comes in, where Sunbird may not run initially, but we've kind of designed the system in a way that we have clear view on what it takes to make it running there. Okay, so it's important to be cloud native, leverage the elasticity of the cloud, but at the same time being agnostic. Okay, security. It's a ever evolving area. So you first start with perimeter security, right? Anybody who does microservices, you start with perimeter security, where you talk about how do you ring fence your APIs from being called by people that you have not authorized. So you put an API gateway, right? But over time you will realize that API gateways take care of perimeter security. They ensure that intruders don't get in. But what they don't really ensure at a great scale is, how do you know that this tenant that you have authorized to create content for that particular tenant is not accidentally or maybe intentionally creating content for another tenant, or deleting content for another tenant. So when you want to get into that level of detail, you need some policy-based security as well. And that's why you will see in Diksha or Sunbird that we have actually put OPA, Open Policy Agent, which is a declarative policy-based engine. So you can keep refining the rules to make it better, make it more secure, and that's the journey that we are into. Observability. So while telemetry gives you the observability of how your users are interacting with the system, the infra observability, like what is the kind of infra utilization your services are happening? What is the disk IOPS when your APIs are running at full throttle? How many transactions per second are you taking? What is the response time of these transactions? So all this comes under observability. Okay, so it's important. So these were our thinking principles, and based on these, we have looked at how do we tackle all these when we have looked at any building block that we have built in Sunbird. Yeah.
Like I have a question on this.
On?
So when you say like cloud native,
Yeah.
so do you actually use a native service for the cloud and do, or
Yeah, so we are compatible. That's what it means. So let me give you an example. So let's say that you want to use an Elasticsearch. Now, there is OpenSearch that is offered by AWS. So if you're going to AWS, Sunbird can work with OpenSearch. But if you're running on a cloud which does not have an Elasticsearch offering, we have the Ansible scripts to help you set up, bootstrap your own Elasticsearch and work with it. Likewise, Redis, Diksha, I think, uses a managed Redis offering. But in IGOT, in NIC, we don't have any managed offerings of databases. So we use the Sunbird scripts to set up our own Redis clusters, our own Elasticsearch clusters and databases.
Kubernetes is one of the.
Yeah, so Kubernetes now I think is transformed like an operating system for microservices, which any cloud provider will have a Kubernetes offering, and we have ensured that the entire microservices layer is compatible with Kubernetes. So if you have a Kubernetes offering from any cloud, the system would work there.
So my question was in a different way, like if I go to like AWS for like event processing.
Yeah, yeah.
Then we have a Kinesis.
Yes.
So would this guy will go and use a Kinesis?
No,
there,
no,
or
no.
for
We have
event apps, or we have already fixed something that is
Yeah,
there I will use,
so
or it's not
we
that
have
installed?
Kinesis is not an open source specification. It is very AWS specific. So the moment you tie your applications to Kinesis, you are pretty much stuck with AWS. So we took a conscious choice that we will be Kafka compatible, and anybody who has a Kafka service offering will use that.
No, because they use the word native. So I'm
Yeah,
looking
yeah,
at
yeah.
that.
So native does. So that's what I'm saying. It is native yet agnostic. So wherever native prevents you from being agnostic, we have chosen the agnostic part of it because we're very clear that
AWS has another AWS MSK also, which is Kafka compatible.
Yeah, yeah.
So it should be able to use that.
Correct. And so does Azure. They have HD Insights, right? So,
Yeah.
I got
Good.
it. Matthew, we just want to focus and say it is primarily agnostic, but
Yes.
you use the native services.
correct,
as
correct.
relevant.
That's right. Where there are native services for the open interfaces that we have used.
Open interface.
Yes.
Because you're not using the native services of the cloud.
Yeah, yeah.
And you did give examples of where are the other clouds is working on. Right?
Yes. This I covered that. Yeah. Okay. So in terms of tech stacks, most of you working on the system would know that this plethora of tech stacks. Now it has been a very difficult choice. A lot of people assume that having more tech stacks is better. It's not, because you then need a lot of skill set to run it. But it is important to realize that when you're building something which has to scale to, let's say, India scale or internet scale, it is important to use the right tool for the job. So every single choice that we have made here has been debated, by a bunch of architects in the system to see, is there any way to avoid using or bringing on this new stack? Is there a way to use something that we are already familiar with? Because it is a learning for the team which is building it. It is a difficult thing for the team which will end up maintaining it, right, or enhancing it. So we've gone through those choices and we had to choose these tech stacks because the system demanded so. Okay. Now we'll actually deep dive into some of the building blocks specifically, not all of them, building blocks, and of course more details will follow in the breakout sessions. But I'd like to start with knowledge platform, which is the content representation, right? Now, if you look at any traditional content management system, a content is just a line or a row in a relational table, right? We could have taken that route. Why did we not? So here we are representing content as a graph, because we think that when you represent content as a graph, the possibilities are endless. Okay? Now, let's say you have a content which actually uses an image. You have a content which tries to link to a question. You have a content which is part of a collection, which is a learning journey. When you represent this as a graph, you are able to query these graph to kind of derive more insights. So the moment you want to look at something like recommendations, you need a graph, right? So the power of graph is well known, and that's why it is a conscious decision that we will actually use a graph to represent content in Sunbird and not have it as a row in a database. Okay. So what we've done is we have abstracted those graph possibilities in a graph manager, and that is interfacing with Neo4j, where the graph is represented. Now I spoke about how databases have to be horizontally scalable. Now the latest versions of Neo4j are horizontally scalable, but the licenses are not friendly, right? So what we have ensured is Neo4j gets used mostly as a content write store. So we have kind of implemented a CQRS kind of pattern there. So all the content writes go into Neo4j, and that is fewer number of people than, because in a content management platform, the creators or editors are fewer, the viewers are more, right? And we have ensured that whoever has to view metadata or search metadata, discover content, gets it from Elasticsearch, right? So it is sort of a CQRS pattern, and of course there's a fair bit of Redis caching as well, because when you're getting called like 3000 times a second, it doesn't make sense to always go to Elasticsearch with the same search query, or to go to Elasticsearch to get the same metadata again and again. You would want to store it in a database which is more cost efficient. So Redis can give you, on a single core, Redis can give you 40,000 transactions a second. Elastic on a core will give you maybe 5,000. So you can see the cost differences that would come in, right? And it was very clear that when we actually wanted to implement this sort of CQRS pattern, any write which happens into Neo4j has to be propagated into Elasticsearch. Now there are two ways of doing it. One, you follow the event-driven approach where whoever is anchoring the write puts a message saying, I have written this data, there is another consumer which would populate Elasticsearch. Now the problem is, there could be a lot of writes, edits and all of that, and it's not very easy to ensure that there's no developer error while doing it. And thankfully Neo4j provided the ability where it provides for a kernel extension where you can get a callback whenever there is a change in the data. So there, now you have suddenly made it independent of your dev team. So we wrote a kernel extension in Neo4j, okay? I mean, kernel sounds dicey, but believe me, it's just Java code, okay? So they call it kernel, it's not us, right? So we wrote a kernel extension in Neo4j, which gets a callback every time there's a change in the data model, and that becomes an event, and that drives the event-driven consumer, which will then index it into Elasticsearch. By doing it this way, we've been able to ensure that the correctness of the developer or the QA is not really coming out here, right, playing out here. And the pipelines that you see below, some of that are for the syncing to Elasticsearch, the audit events, for example, right? I mean, audit events, there are also other audit events which happens like who did what on the content, so that there are explicit audit events also written. And then Flink also gets used for things like content enrichment and the publish pipeline, right? When you publish, let's say you are uploading a MP4 and you want adaptive bitrate streaming to be done. You can do all those when you have the publish pipeline. You can tie up with a media provider, which is again a cloud native option, and for that media provider you can submit these videos and it will give you different URLs for different bit rates, right? So you get all sorts of control like that. So publish pipelines is the place where all these things can be taken care of. How do you fine tune that experience for your end user? How do you make it more efficient for your end user, right? So and it is important to represent content mapped to a taxonomy, because that's when it becomes reusable in other contexts. If you're teaching photosynthesis for class 6 in an English medium school in Karnataka, probably the content is relevant for photosynthesis in an English medium school anywhere else in India. They may choose to have a different content of their own because they have their own style of teaching, but this becomes like a reuse possibility, right? So the taxonomy is what connects the entire knowledge graph, right? So that's pretty much what I wanted to cover on the knowledge platform. Any queries on the knowledge platform? Yeah.
Yeah, so from 4J to Elasticsearch, how it is going? It's like continuous fall or it's going
Right. So there is a kernel extension. Think of it as a jar file that you drop in Neo4j. That gets a callback every time there is a change in the data. That will write it to a file. That will write an event to a file, and we use a logstash process to push it into Kafka, and then it's an async which
Logstash and Neo4j both are on the same machine.
Yes.
And it reads that
Yes.
log file and it writes.
Yes. Which also means that there is a small sync delay that could happen. Now, how do you reduce the risk of that delay? So that's where the observability piece becomes important. So we have a Flink job which is looking at these Kafka topics and ingesting data into Elasticsearch. So it is important that you're monitoring the lags of those jobs and having your NOC team get alerted the moment it crosses a certain threshold, right? And that's already in place.
So in Neo4j itself, I don't know, it's an enterprise version. There's a change data capture plugin also.
Yeah.
But I think that's not part of community. So it can directly connect to the Kafka.
Correct. So the latest versions support a lot of those kind of capabilities.
But that's not part of community.
Yeah, that's what. Neo4j, the license is not very friendly. Yeah.
So how much is the velocity currently coming in for content which is getting into the Neo4j? Is it huge or?
It depends upon the users. So there's a lot of, almost every time you do any content publish, etc., content API you use, then this Neo4j database gets updated.
Yeah.
No, but how much is the load which is coming?
So you can assume that I've seen some of the dashboards when we were cruising at 25,000 TPS, and creation used to be like a minuscule. Not more than 200 TPS goes to creation. The rest is all consumption. So you can have that as a mind map, I would say.
So like Neo4j used for content, right?
Yes.
And the Cassandra, what is the purpose of Cassandra?
Right. So Neo4j is a labeled property graph. You can easily store key value pairs. Okay, so you have vertices and you have edges, right? Both of these can take properties. Now you don't want to put in big volume of properties because that slows down the graph, right? And there are different content types. Now when you look, we have a markup language called ECML, so which allows you to have animated content and all that, right? So when you write ECML, that's like an HTML file. That's big. It can grow to maybe 2 MB, 3 MB and all that. And you don't want to store that kind of data in your property graph. So those are marked as external properties. And when you go into the backend session today, they'll actually tell you how configurable the system is, where you can introduce new properties and indicate that they should be stored in Cassandra through a configuration. So only those aspects anything which is not metadata goes into Cassandra. Anything that is metadata and is important for discovery stays in Neo4j.
And what are we using Redis and Elasticsearch? Definitely we are using for content.
Yeah.
But what other? Is Elasticsearch used for something else also?
In the knowledge platform, the entire content metadata is materialized into Elasticsearch, right? You also have some of the audit events going into Elasticsearch. For like some of the APIs to query audit is actually querying it from Elasticsearch. Yeah.
What about Redis?
So Redis, Redis is used where if you look at content, it is in draft mode for some time. You then send it for review and then you do a publish. So until you publish a newer version, you can afford to keep a copy of the metadata in your cache for faster access, right? Low latency, extremely low latency. Redis will give you like a 1 millisecond, 2 millisecond latency, whereas an Elasticsearch will take maybe a 10 to 12 milliseconds. So it's a factor of 5 or 6. So we have used Redis wherever we thought that it was safe to cache the data, and the microservices rely on Redis for quicker access. And it's a pass-through cache. So if you flush out Redis, it will get repopulated. Yeah, it's a write-through cache. Okay.
Redis is only used for knowledge, right?
No, it's used in multiple places. Yeah. So these technology choices, barring Neo4j, I think the rest of it is used in pretty much every service.
Cloud storage is easy.
Yeah. So when you upload content, let's say there's a PDF or there is a MP4, that gets pushed into cloud storage. Yeah. Even the thumbnail images, for example, get pushed into cloud storage.
And what type of storage in general we are using the storage itself? What the different kind of storage is?
So cloud storage is basically, we have an abstraction layer. I'm actually covering it. How are we thinking cloud agnostic? So that's a topic coming down the line. Your question was, what are the kind of cloud storages we have tried or proven with, right? Yeah, that's covered.
Different requirement, IOPS, different.
Yeah. So with cloud storage, you really don't get to choose your IOPS.
Okay.
You just pay for bandwidth consumed, and the amount of data you're storing there. So they are as elastic as that. I remember, the implementation architect of Diksha telling me that they actually wanted to send out 5 petabytes of traffic monthly, because when you get like 50 million content plays a day, that's the kind of data. 5 petabytes, it's huge. And when they had to send out 5 petabytes of data, they had to talk to Azure and get a sign off that the networks, specifically in India, can support that kind of egress. So when you're on cloud storage, you don't worry about IOPS. IOPS is when you worry about block storage. The block storage is the disk that gets attached to VMs.
So that's your question. Are you using block storage?
Yeah. So all the VMs that we have, including the Kubernetes nodes, will be using block storage. And block storage, typically most clouds, what they do is they give you as many IOPS which is proportional to the amount of storage that you buy from them. So if you are running a database server, and if you have only 10 GB of data, if you buy a 32 GB disk, you get very limited IOPS. So sometimes you'll be forced to go for a 500 GB disk because you want higher IOPS. So those aspects come into play.
One thing I wanted to ask, any sort of a data retention policy which you have designed as a part of the Sunbird itself. So this huge amount of data being generated.
Yes.
But then you won't keep all that data.
Correct.
Right. So what that policy is, how you ensure that that particular piece of data is relevant and you can discard the rest.
So in the databases, we keep all the data.
Yeah.
Okay. But when it comes to cloud storage, whoever is the adopter can choose to define, because each of the cloud storage providers provide life cycles. So for example, when you are talking about 1.5 billion telemetry events a day, that is quite a bit of data. Now you may not want the raw data after 3 months, or if there are regulatory needs, you may have to keep the data for 6 years on demand basis. So you can set up rules to move it to a glacier or an equivalent. Yeah. So it is not, you won't purge the data. 7 years is quite a time frame, right? So you won't purge the data, but you will put it on a lower or a cheaper variation of the cloud storage, and most of the cloud providers provide that capability.
So basically we need to come out with some policy, because
6
years data is there.
Yeah.
The telematic data,
Yeah.
is it required or not? So
Yeah.
yeah.
So that is up to the adopter. For example, in Astrika, we've kept only 1 year of data because we are okay with 1 year of data.
My question is, so if we keep that 5 to 6 years of data, telemetry data,
Yes.
what part of that data would be required? Functionally, why we want to keep it or why we don't want to keep it?
So
I think that's what they're saying. It's all depend on the business users.
yeah.
Correct. Like what I will do like 7 years back, which teacher did or which creator did what, correct? So if I really need it, that will be dictated by the business.
Yeah.
That how long you want to keep.
Correct. Functionally, the system needs this data only for reporting. And if you're running daily reports or monthly reports beyond a month, you really don't need the data. But it's a regulatory thing most of the scenarios.
And then do it.
Yeah.
We insert the telemetry data. So
Yeah.
there we have 2 clusters, roll up and
Yes.
raw cluster.
Yeah.
So roll up cluster has 3 years of data.
Yes.
And the raw cluster has 3 months of data.
Correct. And there's a reason to it.
The retention period that we have already
Correct.
defined.
Correct.
Accordingly, the data sources have been populated. And,
Yes.
the segments are being loaded into the.
Correct. So I have a slide on data. We will touch upon that aspect there. Yeah.
And what is the use of play and occur? The choice of using play and occur.
Good question. That's something I wanted to cover but forgot. Okay. So remember the resiliency part and the non-blocking part.
Yeah.
Now imagine for a moment that you're using a Spring Boot framework to build REST APIs. Now when you use Spring Boot, it is actually a blocking framework. I also have another side where I know that there are projects where Spring Boot makes absolute sense, right? And the complexity of a non-blocking or a resilient frameworks is not required. But let's be aware that when you use a Spring Boot like framework, you have a number of threads and you have a 1 thread per request model, which means when you start up a, sorry? Yeah, it's a servlet based. I mean, servlet has async as well, but Spring Boot hasn't moved there yet. So the challenge is, if you have, let's say, a 250 thread pool, you can concurrently only handle 250 requests, right, in an instance. And what happens if you use that kind of a programming paradigm is, let's say that you want to do auto scaling. Now, what are the rules for auto scaling? You would say that when this container gets to, let's say, 70% of CPU, auto scale, add a second container. Or if you already have two, maybe add two more, right? That's the kind of rule that you want to specify. The moment you use a Spring Boot kind of framework, the challenge you will see is, there are 250 calls coming to you. But what is happening in that Spring Boot application? Most of the time it is just making a database call and waiting for data. So it is in an ideal state. So your objective should be, if I have one Java container, whatever be the server, I want to be able to handle maybe 1,000 requests in that one container, not 250, right? So that's what gets enabled by using a non-blocking framework, and Play framework is one such framework. There are other non-blocking frameworks. So Spring has something called WebFlux now. It's part of the project Reactor. That is also non-blocking.
Basically, they both use Netty basically.
Netty is only the server. Okay, Play framework uses Netty for traffic. So the concept of Netty is, how many of you have tried Node.js? Yeah, so you know about the event loop, right? Right. So the concept of Netty is similar. When a new client comes with a request, they put it into an event loop. So Netty is only accepting traffic. How do you react to that traffic is the Play framework part, right? So that is.
Play framework in combination with Akka.
Yes. Play framework internally uses Akka, correct. So visualize it this way. When you create an actor, you get a queue, okay? And everybody who is trying to call that actor is actually putting a message into that queue. And all the actor is doing is fetching the last received or the last process message, do a +1, read the next message, and it's acting on it, right? So you will not get non-blocking behavior by magically by just using actor models. You also have to ensure that inside that actor code, if you are, let's say, making a database call, that should also be non-blocking code. So it is a combination of multiple factors. I'm sure Mahesh is here. He is the architect for Knowlg. He will be covering some bit more detail in the breakout sessions as well.
But
right?
threading part, I think, handled by the Akka actor, not the Play.
Yeah, so Akka provides the concept of dispatchers and thread pools, so you can control.
Yes. So not the Play framework, right?
So Play framework is a wrapper over all these capabilities. Play framework brings all these together, right? I personally don't see a point in checking what is done by Play versus what is done by Akka. I mean, as a framework, it gives you these capabilities. It's an ecosystem.
But actually in the code, what I've seen that actually Akka actor is handling the threading things or like processing the things rather than the Play framework. In the Play framework, we just define the routes basically and.
Yeah, so it's a combination. It's a combination. So Akka is actually used inside Play. Play uses Akka for the non-blocking side of things. Yeah.
So
okay.
Why not only we use the Node? We use Java.
Yeah. So that was a dev team choice. Okay. So with Node, we have seen multiple problems in recent times. I mean, not just recent times. Even then, it was not maintainability of Node.js applications, because in JavaScript there are like 1,000 ways to do the same things, right? And an enterprise quality code which you want to survive beyond your team tenure, honestly, in JavaScript, I mean, it has its place for quick POCs and quick small applications which you want to build, but otherwise it's not for enterprise things. And that's why you see like most of the banks, most of the retail enterprises, for kind of their order management systems, you will never see them using Node.js. You will go into some enterprise language that used to be Java. Now people are slowly moving into Go and Rust like languages.
Kotlin was also coming up, right?
Yeah.
Kotlin with coroutines and channels.
Yeah.
I think will be a viable alternative which we can evaluate. Like
Go is another alternative.
So yeah, but Kotlin with coroutines and channels. So coroutines is sort of the coroutines plus channels will give the same effect as we are doing the Akka and this thing.
Yeah. Yeah.
But now Akka is a license, business license.
So the version of Play framework that we are using, that is free.
Right.
If you use Akka streams, and Akka is a huge family of libraries. Yeah. So if you use all those advanced things, then you have to be on a commercial license. But the version we are on is still public open source.
Currently Apache, under Apache
Yeah,
only.
yeah.
From 2.6 now they have changed it to BSL.
I think 2.7 also, I think. Maybe 0.8 onwards maybe is. I don't know the exact things, but.
Also BSL is like after 3 years of their life cycle on the BSL, that automatically comes into Apache. That's what the BSL license is.
Yeah.
And even we have used like classic actors only, not the that.
Yeah, so we just wanted the resiliency of the actor model and the non-blocking nature of it. So you choose, because the more and more you tie into actor, then moving away from that at some point becomes difficult as well. So you have to be very choosy on what capability do you need, because all these newer frameworks will give you so many options. But once you start using these options, then you don't know how to come out of it and choose another framework. So you have to take that fine call. Okay, that's a good discussion. So I'll move on to user and org module. So yeah.
You have shown the search middleware. What
Yeah.
is the search middleware?
It's the layer of Akka actors which handle search. Yeah. So user and org module. This is called Lern now, right? And this takes care of how do you onboard users, the registration of users, how do you authenticate users, the role-based access control. It takes care of the multi-tenancy of the system, the representation of organizations, mapping of users to organizations and things like that. And we have chosen Keycloak as the ID provider. Yeah. So what we also did in Keycloak is we ensured that we are only storing credentials in Keycloak. The user profile continues to be in our custom microservice, and we have written custom service provider interfaces in Keycloak to kind of talk to our custom APIs for correct service provider. Yeah. Right. And if you see the verbs that we spoke about are all there on the top, right? So in terms of tech stack, there's no Neo4j here. Postgre is mentioned because Keycloak uses Postgre. Okay, the edge systems, your Kong, Keycloak, all of them, they use Postgre.
But, the user details are typically modeled in Cassandra, right?
Yes. So that is taken care of by the user microservice, and Keycloak calls the user microservice to fetch a user profile, right? So all the organization data, all the user data, the roles, all of that is stored in Cassandra. The mapping of users to organizations, all of that is in Cassandra. Okay, and Cassandra holds a special place we have seen Cassandra scale linearly. If you have a 5-node cluster, you need more capacity, add 2 more. You are on a 7-node cluster, you need more capacity, add 2 more, and you are getting linear scalability. Near linear, of course, there's nothing like true linear in distributed computing, but near linear. So if you are getting like 5,000 writes a second on one cluster with 3 nodes, the moment you add a 4th and a 5th node, it goes to a 5,000 TPS.
How is the consistency like you completed?
Yeah, right. So Cassandra allows you to choose your consistency. So we, by default, Sunbird recommends using a replication of 3. And we have put quorum as the write and read consistency, which means that, you will accept an API will go back to the end user as a write success only if at least 2 nodes have got the data. Both are synced. 2 nodes getting the data means they have it in their stores. And when you're reading, we use quorum. So if the third one hasn't synced and you use quorum, Cassandra internally will sync between the 2, if at all there is a delay. So we have chosen Cassandra for very strategically. We have done tons of testing to prove that Cassandra is the right database, and that has worked beautifully for us. There are other cloud native offerings which are not open specifications. Yeah.
HBase is also there for NoSQL.
HBase is going to be extremely slow compared to a Cassandra. I mean, they
but
compare.
It is fast in the HBase.
Yeah, I mean.
The read throughput is very high in the HBase.
Yes, that's right.
Write throughput will be slow.
Yeah, so the advantage of Cassandra is that is probably the only open source offering where writes are linearly scalable. And I spoke about, if your challenge is only read scaling, because the moment you switch to something like a Cassandra, you are giving away your ACID compliances, right? So exactly, you can have tens of read replicas for a SQL database, right? So it is intense writes that you want to do the moment, and that's when Cassandra becomes like a viable option. I mean, there are equivalents. There's something called Scylla as well, which is like a Cassandra written in C++. So
again, is not under open source umbrella. It's a company which has open sourced its product.
Yeah.
But it may go in
Yeah.
some sort of an enterprise.
yeah, yeah,
But
yeah.
the read throughput with the Cassandra will be low. Sometimes you will get timeout exception when you
So,
not on the partitioned or indexed column.
So that's what you are giving
That
away.
will have another limitations of Cassandra.
Correct, and which is why, so when you use Cassandra, you can only query by the primary keys. So which means that if you want to query by other keys, you have to materialize the data into something like an Elasticsearch. Otherwise, if you query by non-primary keys, God bless you. I mean, that's how I would put it.
Is data modeling also matter while using the Cassandra?
Yes.
Data
So
modeling primary.
correct.
I have one question. I don't know if it's related to user or not, but in Cassandra, in content, I have seen mostly there are some triggers also written.
They are not used.
No, they are used because we were doing one of the dev environment setup, whereas those triggers were crucial for content to be published.
Like
Otherwise-
this, like content hierarchy table is there.
there's
No,
one-
the triggers, as far as I remember, were an experimental feature. It's not required for the.
Currently in 5.1 they are being used,
Okay.
and I just want to understand what those triggers do and why they are.
So we will, in the breakout sessions, I think we will touch upon that. We can look at the specific problem you are facing as well. Okay. You may face a problem that the trigger is not present, but the moment you add the trigger, it does nothing. So
Acha, okay.
that's how I would put it.
No, but we had a session with Santosh Gandham also. He said that that trigger is necessary for the screen to proceed ahead.
Okay.
And we were missing that trigger because it was giving that trigger not found.
Correct. So sometimes the trigger has to be present, but it's actually not doing any processing. Yeah. So we'll touch upon that in the breakout. Yes.
So, but then why we are having the dependency? Can't we just remove it out?
So that is legacy reasons. Once you have a migration which has a trigger, you can't just wipe it out, right? So it's due to that. Okay.
You said that you are storing the user credentials in the key clock.
Yes.
So what if we are doing the sign in through the Google or Apple?
So when you're doing a sign in with Google or Apple, right, your authentication is handled by those providers. And when they come back, what happens is the portal actually verifies if the token that you're coming back from Google, let's take Google, is a valid token. And if it's a valid token, there is a bridge from the portal to Keycloak to say, I trust this user, give me a Keycloak token for this user. There's an interface to do that, and that's what gets leveraged.
That decision also happened through the key clock. We can say that.
No, decision is not in Keycloak. Decision is on the portal whether you trust the user. And once you trust the user, you have to issue a Keycloak token so that all your microservices, they trust your Keycloak token, not Google's token, right? So that exchange of Google's token or the translation of the Google's token to your Keycloak token happens in the portal.
So for every platform we are sign in through the portal or
Yeah.
Android or iOS, we need to have a a proper setup in the key clock.
Yes.
For every platform.
Yes.
Project in
So it will
Keycloak
be-
for that, iOS.
Sorry?
Yeah.
We need to create project
Project
in
for
Keycloak.
iOS.
Yes, because there is a specific client which has to connect to.
Because currently we have checked there is no project for iOS.
Right.
So basically in 5.10, I think
Yeah.
in prod there is a web view for iOS
Correct.
for doing the authentication.
Right. So using clients is a choice actually. I mean, technically you can have all your portal, your Android apps and iOS also use the same client because you are in the same realm. But it is neater to segregate them and keep specific clients because you can then attach behavior to those clients as well.
So currently for the login with key clock process also, we don't have any project for iOS. So why, I mean, you said that we need to segregate everything.
It's a good practice. Now,
How it's handled in above version, like 6 version is there, na? So it's
Even in-
handled in 6.0 version.
no, the client is, see, the client is just a string which you put in your code. Now, somebody would have assumed, I'm assuming, okay, here, that when you put Android, then somebody would have thought that it's all of mobility is on that client. That's what would have happened. Now, you can feel free to segregate it as iOS and thing, and it's just changing a string in the code. Yeah. But you don't get any additional benefits unless you actually configure the clients with any specific behavior.
So for the current setup in 5.1 we are talking about, so there is only one client for Android and iOS.
Right.
Right.
Yeah.
So
And
only
you,
for-
it will work. Like I said, only if you want to differentiate behavior between iOS logins and Android logins, you actually need to create a new client. Okay.
And again, for Keycloak, can we do scaling
Yeah. So you can add more nodes for key clock.
We need to rebuild that key clock model then again?
No. You just have to provision. You can add more nodes. So key clock uses a TCP ping to identify the cluster members. So every time you create, once you provision a new node in key clock and you create a new key clock node, it will automatically talk to there's a J group ping stable or something in Postgre. It will automatically talk to it and it will join the cluster. So that is taken care of. So it can scale linearly.
But again, for scaling, we need to add node there.
Yes. So if your question is, could it not have been on Kubernetes? That's an opportunity for you to like take it to Kubernetes, because then you can have auto scaling there as well. Yeah.
But here we have like manual, we need to add nodes.
Correct.
If we move on Kubernetes, then we can do it.
Correct. So that's something you can always do. It's pretty easy to kind of move a service which is running on a VM to Kubernetes these days, right? So it's a choice.
Yes, Mathew.
Yeah.
How exactly this works? Like suppose an anonymous user.
Huh.
Okay. In that case, key clock nothing.
No.
Okay. And if a Google user, okay, if he logs in during that time, how the flow will be?
Okay. So what happens in the case of an anonymous user is we issue a you are actually relying on a pre-created token, which means, and that pre-created token has only certain access privileges. You cannot call any of the APIs which require user context. The only things you can do is send telemetry, read the user content metadata, hierarchy metadata, and play content. So we have ensured that the token, the default token that gets used for anonymous users is only allowed to call these select APIs.
Okay.
Once you log in and you get a user token, then you can start progress tracking and things like that. That's why for anonymous users we don't allow progress tracking, because there's no profile that exists.
So if in case the user is not logged in, so gets used.
Yeah.
So how the token works in that case?
So there is a token which is embedded in the portal, right? And that, so there are few APIs which do not require user specific tokens, like content read, content hierarchy, send telemetry. You don't need user search, right? Good. So you don't need user specific tokens. So what happens is the API token that gets used for anonymous users has access only to these APIs. The other APIs, like the moment you say get user profile, you need a key clock token. Or the moment you say read your content state for this course, you need a user specific token. So that's why for anonymous users we don't support all those endpoints. Yeah.
Say, again in key clock, are you storing that like Google, through Google if I access? So where you are storing the credentials?
No, there are no credentials with respect to Google.
So where, how exactly it works?
So the portal will do a OpenID Connect handshake with Google servers, and Google will send you an authorization code. The portal it has an API to verify that authorization code was issued by Google. It does some time check and all that, it is not older than 2 minutes and all that. That gets taken care of by the client library. And once you trust the user, you know that he is actually this Gmail ID, then you will use a bridge that you have to key